Assalamualaikum warahmatullahi wabarakatuh to my dearest lecturer, Puan Hidayah Rahmalan. My name is Altra binti Lokman. I will present to you my report on selected research paper for midterm. I choose recent development of content-based image retrieval. So now I will share my slide first. Okay. So before we start, let's get to know what is before content-based image retrieval. Before content-based image retrieval, we have tag-based image retrieval. Okay, how to get image like this or similar to this? Before we have CBIR, we have text-based image retrieval. We use variety of description and text such as we can see in the picture, it is a sunset. And then by the beach with a coconut tree. Yeah, we use a lot of description and text. So what if we have a lot of description and every people have a different interpretation? Yeah. It is called limitation of tag-based image retrieval. The first one is label intensive. What if there are lots of text? And the second is imprecise, unreliable because the text is depending on people perception. Different people have this different perception. Maybe I can see the previous image as sunset, but some people might see it as a dawn. So, as for the solution, we have content-based image retrieval. What is content-based image retrieval? Content-based image retrieval is when we input a photo and then it will query the database and the output will be variety of similar photo to the input at the first. So how does it work? It see the image color, texture and shape. The second one, it will compare features of image with image in the database. And then it will compute distance between features of the image and return sets of image, least distance from original. Yeah, as I told you before. Let's say we put a photo of a cat on a chair, and then on the second step it will compare the features such as cat, chair, maybe chair on the floor, inside houses, and then it will compute the distance between features of image. It will look through in the database for image that has similar features and then return set of image least distant from the original to user. So basically, CBIR is a technique that can retrieve related image from a database with an input image of the object or content we are interested. The next one is the general flowchart overview for CBIR. CBIR is a abbreviation for content-based image retrieval. So this is the general flowchart. As we can see, it is divided into two stages, which is online and offline. For online, the image will be queried to see the feature extraction, and then it will search and scoring, and then ranking and show us the result. For the online, it will retrieve database and search for feature extraction, and lastly, build database indexing. Okay, so next, as we can see in this general flowchart, there are two major components of content-based image retrieval. The first one is image representation and second one is database indexing. As we can see, both of the components are there for online and offline state. So next, we will talk about image representation. Image representation is the key step that extract the critical features from a given image and then transform them into a fixed size vector. So there are three image representation features. The first one is conventional feature-based method. The second one is classification CNN feature-based method. And the third one is retrieval CNN feature-based method. So we will go through one by one. The first one is conventional feature-based method. It is a feature which are not being extracted through any convolutional neural network method. Okay, we have two categories for this conventional feature. The first one is the global and second one is local features. For global, usually is extracted from the color, shape, texture and structure of an image respectively and then transferred into holistic representation, while local feature, it will extract the features on the dense grid, possibly at multiple scale independently of the image content. Scale invariant feature transform, your abbreviation is SIFT, involve interest point detection and local region detection. Okay, of course there are the pro and cons. So for the global features, it is suitable for duplicate detection in a large scale image database because it is compact expression, but they may not work well when the target image involves some background clutters. And for the local features, since it have different kinds of superiority as claimed, it is rather difficult to select the best one for the retrieval task. So the next features is classification, CNN feature-based method. Okay, as for this second method, it also has global and local, but we will go through for the local features. Local features for CNN feature-based method is that it has three. The first one is local representation aggregation. The second one is deep convolutional feature aggregation. And the third one is multi-layer fusion. So, this method can produce compact embedding features to enable fast similarity computation in the filtering step, but may lack a description of the details of the image, which is not so significant for image retrieval. So, for the local representation aggregation, it has classified into three categories. The first one is local area extraction based on the sliding window. Okay, by sliding the input image with a series of different sliding windows to create partial area. The second category is region of interest detection by implementing some specific detection algorithm to extract the region of interest in the input image. And the third category is local area extraction based on region proposal. It is based on region proposal and utilize some specific unsupervised candidate region, generate algorithm to obtain local candidate region that may contain target. This method require multiple feed-forward networks, so the efficiency become the bottlenecks. So the next one is deep convolutional feature aggregation. This method can be regarded as description of the local area of input image. Only feed the network once to generate deep convolutional features and aggregate them to get final description of the image. It can be classified into two. The first one is direct aggregation. They use some specific aggregation method to aggregate the deep convolutional features to obtain the final image representation. And the second one is weighted aggregation. So the third one is multi-layer fusion. Multi-layer, it is called multi-layer because the deep CNN features are hierarchical that change from a low-level visual to high-level semantic features as layers to deeper. As the deep convolutional feature aggregation method aim to complement the information of different layer features in deep neural network to synthesize the invariance and discriminative ability of different layer features. This can be further fused multi-layer features together. So the third one is retrieval CNN features-based method. Okay, we use hard negative mining technique to retrieve method based on retrieval CNN features, and the type of hard negative mining technique, we have three. The first one is semi-hard mining. The second one is smart mining, and the third one is distant weighted sampling. Okay, retrieval method based on retrieval CNN feature employ all below loss function, which is contractive loss, triplet center loss, quadruplet loss, lifted structure loss, and pair loss, binomial deviant loss, histogram loss, angular loss, distant weighted margin based loss, and hierarchy triple loss. So next, our fifth topic is database indexing and search. Okay, this is the second major component in content-based image retrieval. Okay, so let's begin. Database indexing search is with the effective image representation of feature vector. We can further establish a database indexing method for the content-based image retrieval system and search with the image indexes via a similarity measure. We have two features for this database indexing or search. The first one is feature direct database search, and number two is feature utilize database search. The difference is between direct and utilize. So the first one is feature direct database search. It utilizes the feature vector of each image as an index for database search. Okay, we have several efficient methods that are being used in this feature direct database search. The first one is by speed up the retrieval process by inverted file index technique. The second one is narrow the search route by hierarchical clustering on k-dimensional tree, KD tree. The third one is using inverted file index. The fourth one is by improving from original IFI to the new one. The fourth is embed semantic information in the inverted table. And the last one is improve algorithm to speed up the retrieval. So the next one is feature utilize database search. Feature utilized database search is to reduce the computational complexity of the distance by mapping the high dimensional floating point feature vector into the low dimensional vector or binary vector. The hashing based indexing method, which compresses an image into a series of hashing codes so that the search can be translated into a comparison of the Hamming distances among the hashing codes. It is commonly used database search method. So as you can see, this is the chart for this one feature utilized database search for the hash-based method. So for hash-based method, we have two categories, which is data independent method and data dependent method. Data independent method generate independently without any information of training data, while data dependent is it generate with information and training data. So for the data dependent method, we have classified into two categories, which is unsupervised hashing method and supervised hashing method. The unsupervised hashing method only use the information training data set without label information to guide training stage, while the supervised, of course, use information with label. So for the supervised hashing method, we have to next category, which is traditional method and CNN based method. For the traditional method, it can use the label of image to generate a higher precision score of hash code. For next topic, we will look at the practical application of content-based image retrieval. So, the first one is using in fashion image retrieval. Fashion image retrieval is the task of finding fashion image similar to any query image, which satisfy the needs of user. It is mainly related to the cross-domain fashion image retrieval, which is to match two kinds of image. One kind is casually taken by users and another is professionally taken by the seller. There are three challenges faced by fashion image retrieval, which are item clothing are highly deformable, viewpoint of image are severely changeable, and the shooting environment such as lighting and various. Okay, fashion image retrieval, buyer, let's say that last week or maybe 2 weeks before Raya, I found one baju kurung design that I love the most, but it is too expensive. So I use these features like fashion image retrieval to find similar photo like similar pattern like my finding last week before Raya, and then yeah, it used this. But as we talked, they have challenge like I might not get what similar design to my initial design because of the lighting and the background. Maybe I take the photo in using my room temperature, room lighting, but of course the product, the baju kurung is using studio lighting. So there are some method proposed by some researcher. Okay, we have a Gadget et al. For him, he paid much attention to improving training process and inference time. And then visual attention model, it trained two stream network with an attention branch and a global convolutional branch to form an end-to-end network structure. And for FashionNet, it trained network using a triplet loss, while for ZAO, it proposed an adversarial network for hard triplet generation to optimize the network ability in distinguishing similar example of different categories, as well as grouping various example on the same categories. So the second application is person re-identification. Person re-identification, the abbreviation is ReID, is known as person retrieval. It will match the image of the same individual captured on different camera views, and it is usually considered as a sub-problem of image retrieval. It can retrieve specific pedestrian target in the cross-device image, video, and make up for the viewing angle limitation of the current fixed camera. There are example application. It is intelligent security, intelligent video surveillance, and intelligent retrieval. The main challenges in this person re-identification is the first one, the image from different camera views are differ from each other significantly because of the variant of background and appearance, such as illumination, pose, occlusion, and resolution. It all affect the picture. And the second one, there exists some interference of similar image with different identities. And the third one, changes in human pose and human body occlusion may make the problem more complicated. Solution, okay, there are two theoretical perspectives. The first one is to learn effective representation for improving retrieval information, and the second one is to put effort in deep metric learning. Okay, for the first theoretical perspective, it is the method is based on attention. The next method are based on guided pause. Method are guided by mass because neglecting the problem background clutter can lead to degraded performance, and the methods employ generative adversarial network (GAN). Okay, this four method is you should learn this as effective representation. So for the second theoretical perspective, mostly existing ReID framework are optimized by constructive loss and triplet loss. So the importance of good baseline to method comparison in evaluation. The first one, it is essential lead to an unfair comparison between the different person ReID approaches without a public baseline. And the second one is significant to judge the objective capacity of the existing CNN best person re-identification method. So the third application is using e-commerce product retrieval. E-commerce product retrieval is one of the most important features on e-commerce platforms such as Alibaba, eBay, Walmart, Shopee, Zalora, and many more that we cannot name it now. Okay, e-commerce product retrieval will help consumers search the product they want based on the image that they have. I always use these features on Shopee because we can get lots cheaper price on Shopee based on Zalora. Okay. By the way, however, e-commerce product retrieval is a challenging task because the first one is very difficult to handle heterogeneous image data and bridge the gap between real shot images from users and the online image. And the second one is dealing with large scale indexing for massive updating data is also not an easy thing. So solution, we have solution from several people, several researchers. The first one, Wang et al. And friend. It utilized the saliency box to filter the proposal extracted by selective searching. and then propose channel weighting generalized mean pooling feature which preserve the discriminability and correlation of convolution features to improve retrieval performance. While Pai Litau from Alibaba, he focus on building a real-time and stable search engine. It uses binary indexing and re-ranking to improve the engagement, which allow users to freely take photos and to find identical items with millisecond response and lossless recall in a highly available and scalable solution. Yamaguchi et al. He proposed an image representation method with query features transformation, which narrow the gap between query vector and image vector on retrieval dataset. And the last one, Magnani, he go for an exploration of train various product retrieval model trained on search log data to further improve retrieval performance. The fourth application is remote sensing image retrieval. Content-based remote sensoring image retrieval, the abbreviation is CBR-SIR, is used to solve important problems such as weather prediction, climate monitoring, urban planning, geological analysis, disaster monitoring, and resource investigation. This is a key problem that could effectively retrieve the remote sensing image that user need from a large-scale image databases and has attracted an extensive attention from researchers all over the world, because it is in use all over the world. Okay, so from this remote sensing image retrieval, there are two improvements. The first one is a feature-based. The feature-based improve retrieval performance by extracting more discriminative and powerful feature. Okay, we have four researchers. The first one is show. It proposed a combined color and texture features to improve the performance of RSIR remote sensor. And then Lee and Friend, it combined the deep features and conventional features to represent remote sensing image. Then use collaborative affinity metric fusion to get the retrieval result. Zhao and Friend proposed two effective schemes for RSIR fine-tuning and pre-train CNN on a remote sensing dataset, and using a novel CNN architecture based on convolutional layer and a 3-layer perceptron which has fewer parameters to learn how dimensional features from limited labeled image. While Hugh introduced multi-scale concatenation for convolutional features and multi-patch pooling for fully connected layer to RSIR. Okay, we have another three. You can read. I can help. But Shaw presented a novel triplet deep neural network based metric learning method to enhance RSIR. Xiong proposed a new attention module for feature extraction for CBR-SIR, which could pay more attention to the salient features and suppress the less useful one. G present an RSIR method based on weighted distance and CNN. First, it used the fine-tuned CNN model to extract image feature and label the class of image in the retrieval dataset, and then it calculates the weight of each class according to the probability of the query image belonging to each class, and use it to adjust the distance between the query image and the retrieved image. So the next improvement is by the H-best. It will speed up retrieval in large-scale data set by optimizing the database search. Okay, Demi and Friend introduced a kernel-based hashing method that learn function in the kernel space from handcrafted features to enhance the retrieval efficiency. Wiley introduced a deep hashing neural network, DHNN, which could jointly learn to the deep features and deep hashing code utilizing a cross-entropy loss for large-scale remote sensor. And Roy present a metric learning-based deep hashing network, MILAN, that learn a semantic-based metric space while simultaneously producing binary hash code for fast and accurate retrieval of remote sensing image. So the last application is used for trademark image retrieval. Trademark is the symbol of enterprise brand. So to protect the trademark from infringement and piracy is of great significance to promote the development of enterprise and protect the interest of consumer. Trademark image retrieval, the abbreviation is TIR, can search all trademark images that are similar or related to a given input from a trademark dataset. Okay, there are several approaches. The first one is conventional features. Okay, Thurston proposed the color histogram, gradient orientation histogram, LBP shape context SIF and triangular SIF features to search trademark images on their published dataset, while Fang and Friend extract reversal invariancy features from edges of the segmented block of a trademark and then aggregate the SIF features from each block to generate a single global representation. Okay, of course, it has a problem. It is limited in presentation and it has complex calculation. Next, we have CNN features. CNN features, there are also several researchers. The first one is Ecker and Friend. They provide analysis on PR with deep features and show that deep features were superior to conventional features. Len and Friend utilize high-level convolutional features extracted from a pre-trained network and apply uniform local binary pattern LBP to features mapped for aggregation, while Thurston and Friend provide a large-scale dataset with benchmark query. It is a Me-Too dataset. Okay, they provide a baseline on this benchmark using a widely used method applied in TIR in the literature. Recently, they propose both hard and soft attention approach, which directly focus on critical information and reduce the attention given to distracting and uninformative elements. Okay, so CNN features achieve a new state of the art result on Me-Too dataset. So CNN features is the solution for these convolutional features. Okay, next topic, we will talk about the future research direction. Okay, in the research, if you want to do similar like this, the first one we have to collect more and large data set. The more data set, the good output can be. And the second one is establishing effective learning strategy for small scale image retrieval. Because as you can see, it more focus on the big scale. And the third, establish more efficient database search by, maybe we have to make up with new algorithm. And the last one, by adopting of the automated machine learning and neural architecture search. Okay, so that's all from me today. So the conclusion for this general paper is I can see that multimedia for this subject, it is related to the AI subject, where I can see like a neural network and then several terms that related to the AI. So I think it is good because not only we know term for the database, but we also get to know everything about the AI, not everything on the bottom, on the top only. So I think that's all from me today. Thank you very much. So this is the link of resources, and thank you very much.